Hello friends, welcome to video lecture on engineering mechanics. In our today's session, we'll continue with the problems on kinematics of rigid bodies. So let us continue with the numericals on the same topic. So here is the first problem. A bar AB 3 meter long slides down the plane as shown in figure. The velocity of end A is 3.6 meter per second to right. Determine the angular velocity of AB, velocity of end B, and velocity of center C at the instant shown. So first of all, you have to draw this diagram in such a way that we can locate the instant center I. For that, see what's about the information given. So in this case, the velocity of end A is 3.6 meter per second to the right. This information with us. Okay, so apart from this one, the dimensional information with us. Okay, now redraw this diagram here in this way. Now see the information regarding the velocity at point A with us. The tendency of this A point to slide towards the right side. Now the magnitude of the velocity with us VA equals to 3.6 meter per second. Okay, now at the same time, when this will start slide by taking the reference of this horizontal plane, the tendency of this B point to slide in the downward direction by taking the reference of this plane. Okay, now this is the direction of the velocity component at point B. Now we have to draw one line perpendicular to this velocity component at point A. Okay, so draw this line in this way. So perpendicular to this line. Okay, now keep this line pending as it is, and with respect to this B point, by taking the reference of this velocity vector, that is VB, draw one line perpendicular to this VB vector. Okay, now this line and this line intersect at point I. So this point indicate here the instantaneous center of rotation. Now let me clear to you here. So whatever the dimensions given, according to that, first of all, you have to redraw this diagram. Redraw this diagram with some suitable scale. Here a 3 meter length, 3 meter length is given for this one, AB. So whatever the 3 meter with us, okay. For that, take some suitable scale, okay. So this one 60-degree angle with us, 30-degree angle with us, okay. So according to this one, okay. First of all, draw this diagram, and after that, by seeing the direction of this one velocity components. So here is the VA, linear velocity at point A, and here is the linear velocity at point B. So already the explanation regarding the location of this I is given here. Now our target is to calculate the velocity at the center also. Okay, if you just see here the angular velocity of the AB, we have to determine the angular velocity of the link AB, then velocity of end B, and next one velocity of center C at that instant. Now here is the C point with us. Now with respect to this C point, draw one line exact perpendicular, or by if you just see, here is the point C lies on this link. Okay, so you have to draw one component here in this way. So this component is nothing but the VC component, and just join this point with the instantaneous center point. Okay, so here we can get this one VC component. Okay, so once we join this point with this one, we have to draw one line perpendicular this one. So this is nothing but the vector VC. Now from geometry, if you just see here, the C point is exact middle of this link or bar AB. That's why this distance and this distance we can get half of the total distance. So 3 meter with us, so half of 3 meter we can get the 1.5 meter. Here we can get the 1.5 meter. So if you look towards this angle given 30-degree with us, automatically you can get this angle as 60-degree. Okay, so here from geometry, this angle is given 60-degree, means this angle must be 120-degree. So this angle 120-degree, this one 30-degree, automatically this angle must be 30-degree. So if this angle is 30-degree, the remaining one must be 60 degree. So this angle is 60 degree with us, this angle is 60 degree with us, so this angle is also 60 degree. So what's about this one? If angle, this one, this angle, this angle and this angle is same, automatically we can get the length for this side, this one and this one is same. Why? Because of the equilateral triangle. So once we draw this diagram, then you just see here the equilateral triangle with us. So my aim is here to get the various lengths, that is IA, IB, IC, etc. Okay. Now what's about the IA? IA from this geometry, by considering the equilateral triangle. So what's about this one? 3 meter with us. So what's about the length for this one? We can get the 3 meter. Can also get the 3 meter for this IB. So already this one written here. Now just focus on this diagram once again. So what's about this VA? So this is the basic formula with us. V is nothing but the R omega. Okay. So what's about the VA? So with respect to this one, distance center I, we need to take the distance, that is IA multiplied by omega AB. So what's about this VA? VA already given in the problem, 3.6 meter per second. So what's about IA? IA, we can get this information. IA with us as per equilateral triangle with us. From that we can get the 3 meter. Okay, substitute the value for this I as 3 meter. So in this stage we can get the omega AB. This omega AB is nothing but the angular velocity of this rod AB. Okay, so after doing calculation, 3.6 divided by 3, we can get 1.2 radian per second. So if you just focus on this B point, initially we have considered this one A point, now consider this B point. So with respect to this B point, write this formula. So VB is nothing but the IB multiplied by angular velocity of same rod, that is AB. So omega AB is written here. So omega AB already with us 1.2, IB already with us 3 meter. Okay, just substitute here, do the calculation. In this way you can get the VB equals to 3.6 meter per second. Now already actually this direction we know, this makes an angle, how much? Makes an angle 60 degree with the horizontal line. Now my task here, if you just see the velocity of end B, already we get the magnitude for the same, then angular velocity we have calculated. My next task is to get the velocity of the center C. Here is that C point with us. Now to get this one velocity at point C, we need the distance IC. Easily we can get that distance IC by using sine rule. So sine rule here is nothing but the AC divided by, so see this is the front line with us, so AC divided by sine of 30 equals to IC divided by sine, you see IC is nothing but the front side to this angle, so IC divided by sine of 60. If I continue the same actually for the next one, IA divided by, so what's about this one, sine of 90 will come here, but my aim is to get the value for this one IC. Already the value for the this one length for the AC with us, so AC divided by sine of 30 equals to IC divided by sine of 60. Okay, so from this relation we can get by equating this one, so sine 60 will come here. Okay, sine 60 multiplied by 1.5 divided by sine of 30, easily you can get the value for the IC. So once you get the value for the IC, use the same formula, that is VC equals to IC multiplied by omega AB. So IC with us 2.598 multiplied by omega AB, already calculations done by us in the previous step, that is 1.2 radian per second. Just substitute here and get the value for the VC. So this indicate the velocity at point C. So VC equals to 3.12 meter per second. Okay, so this is the answer for the velocity at midpoint, okay, of this bar. And then angular velocity at point angular velocity of this bar AB is nothing but 1.2 meter 1.2 radian per second. Okay, and the next one is nothing but the velocity at point B, linear velocity at point B is nothing but the 3.6 meter per second. I hope this problem clear to you. We'll move towards the next one. In the linkage shown in figure, the link AB at an instant is rotating in clockwise direction and point B has a linear speed of 2 meter per second. find the angular velocities of bar BC and CD and the velocity of pin C. Now look towards this linkage mechanism carefully. So in this case, AB, the link AB at an instant is rotating in clockwise direction. This is the information given. Okay, so whatever the linkage mechanism or whatever the diagram is given, you have to redraw that diagram here in this way. Just focus on this original diagram. So original diagram is drawn here. Now see the information. The link AB at an instant is rotating in clockwise direction. So this will rotate in clockwise direction. Already this one shown here. So you need to consider some suitable scale for this one, or just see here 100 mm is given, 800 mm is given. Okay, so here just consider the for this 100 mm equals to 10 mm or 20 mm. Okay, and just complete this diagram here. First of all, you just see whatever the space available with us, according to that you need to take some suitable scale, or you just draw this diagram as it is. So already we are just doing here calculation by using trigonometric functions or sine rule or cosine rule. Okay, only if you draw the diagram and be able to plot this one I point, then our task is over. Okay, now so whatever the dimensions given, need to draw this diagram here. Okay, so here the length for this link CD with us 100 mm, and just consider as 10 centimeter. Okay, so here 800 mm with us. Okay, so according to scale here we can get the 8 centimeter. Okay, so what's about this one here, the 90 mm with us. Okay, means if we just take this one as 9 mm, okay, then this diagram will completed. So next to this one, this will start rotate about this point, this link AB start rotate about this point in clockwise direction. So clockwise direction means this component comes exact perpendicular to this link. Okay, initially just focus on this link AB, then BC and CD. Just assume that this actually not shown by us here. So this component will come here exact perpendicular to this line. Then move towards next one, and the point B has linear speed of 2 meter per second. So point B has linear speed is given, means the value for the VB with us 2 meter per second. Find the angular velocities of bar BC and this one CD and the velocity of pin C. So here you have to find out the angular velocity of the BC, CD and the velocity at point C. Now once this start rotate in clockwise direction, this component will come exact perpendicular to this link. So when this will start rotating in clockwise direction, automatically the tendency of this link to move in opposite direction. When this will start moves in opposite direction, means this VC component will comes exact perpendicular to this link. Okay, so once this actually drawn by us here, now exact perpendicular to this component, just draw one line passing from this link and perpendicular to this line. Okay, just extend this line in this way and extend the line perpendicular to this VB component. Both the lines meet or intersect at point I. This point I is nothing but the instantaneous center of rotation. So this angle with a 60 degree, this angle is 60 degree, means automatically this angle we can get 60 degree. Once again, if you just focus here, I, B, C, this is nothing but the equilateral triangle. So this length with us 0.8 meter or 800 mm, means the length for this IC and length for this IB must be 0.8 meter. Now just see the various steps. The type of the motion performed by each link is as follows. Now if you just consider the various link, AB link, then BC link and CD link. Now by considering the reference of this A point, this is the fixed point with us. Now the pure rotational motion is possessed by this link AB. At the same time, if you just focus on this CD link, the CD link also possesses the pure rotational motion. Okay, and if you just focus on this BC link, this possesses the general plane motion, because the tendency of this B point to just slide here. At the same time, the tendency of this one C point is also possess the linear velocity. Okay, means this possess the general plane motion. Okay, now already this information is written here. The rod AB possess the pure rotation by taking the center A, then BC possess the general plane motion, then CD possess the pure rotational motion. In this case, the information regarding the linear velocity at point B with us, that is 2 meter per second, is given. Now by considering this IBC as equilateral triangle, in this case BC, already I discussed about this one, BC equals to IC equals to this IB equals to 0.8 meter. Now consider the rod BC. If I consider the rod BC and if I consider the point, this one, end B of this rod BC, so what do we get here? VB is nothing but IB multiplied by angular velocity of same link. So what's about the angular velocity? My target is to get the value for the angular velocity of the link BC. Okay, so VB already given, so that's why this formula, or that's why this relation is done here. So VB with us 2 meter per second, substitute here. IB from this diagram, IB with us 0.8 meter, just replace this IB by 0.8 meter, and just see here, solve this, we can get the omega BC. So omega BC, after doing calculation, we can get 2.5 radian per second. So what's about this C point? So C point is here. So C point is nothing but the another end of this rod BC. So here VC is nothing but the IC multiplied by omega BC. Omega BC already from the previous step, the value for the omega BC with us 2.5. So what's about this IC 0.8 with us? Okay. So what's about this VC? VC is nothing but the 2 meter per second. Okay. So after doing calculation, we can get the VC equals to 2 meter per second. Now, if I consider the rod, this one CD. So by considering the rod CD, we can get this relation VC equals to CD multiplied by omega CD. So what's about the CD? CD with us CD, the length for the CD with us 0.1 meter. Okay, multiplied by omega CD. So what's about this one? BC equals to 0.1 multiplied by CD. For that, already the value for the BC with us 2 meter per second. Just substitute the value for VC equals to 2 meter per second here. Okay, and do the calculations for the omega CD. So omega CD we can get 20 radian per second. So this one we have calculated, this one we have calculated. Our task is over. Our task is to find the angular velocities of bar BC and CD. Angular velocity of BC and CD we have calculated. At the same time, the velocity of the pin C, velocity of the pin C or point, actually at point C already we have calculated. Now we'll move to us next problem. Crank OA rotates at 60 rpm in clockwise sense. In the position shown, theta equals to 40 degree. Just focus here, the value for the theta is given 40 degree. Then determine the angular velocity of link AB. Okay, this is the link AB with us, and the velocity of B, which is constrained to move in horizontal cylinder. Okay, just as far as concerned with our study, just focus or just imagine that only the links in front of you. First link is here, next link is here, next one is here. Okay, the fixed link with us here. Okay, now whatever the information given, crank OA rotates at 60 rpm. So omega OA, the value for the n is given here. Instead of saying here this one 60 rpm revolutions per minute, the value for the n with us. Okay, so relation between the omega and n is nothing but the 2 pi n divided by 60. 2 pi n divided by 60. Okay, so 2 pi multiplied by this 60 divided by 60. So we can get that omega OA in terms of radian per second. Okay, so here 60 get cancelled, we can get the omega OA equals to 2 pi radian per second. So what's about if you just see here, as per first step, you have to redraw this diagram. Redraw this diagram here, okay, by using some suitable scale here, okay. So here 300 mm, 300 mm is given, means you can just take this one as 30 mm or 3 centimeter, okay. So what's about for this one 800 mm, you can just take as 80 mm or 8 centimeter, okay. So this angle with us 40 degree, okay. First of all, complete this diagram. Now what's about this one 40-degree angle with us, okay. So if you just focus here on this angle 40 degree, and if you just first of all uh, as per the motion of this link, first of all complete this one, or complete the location of instead center, okay. Then we'll just move towards this again, come back towards the geometry of this one, how we can get the angles, okay. So in this case, the tendency of this one oiling to rotate about this point in clockwise direction, okay, clockwise direction. So what's about this one, you can get this component VA. Here VA component must be drawn here perpendicular to this link, okay. And see the direction with us in clockwise direction. So exactly in that direction you have drawn the perpendicular to this OA. So what's about the component, VA component will come here. Now by taking the reference of this one, if you just see here, the tendency of this slider or the cylinder to move towards this direction. Why? Because the tendency of this link to move towards this direction, at the same time the tendency of this rod again to move towards this one right direction. So by taking the reference of this one, the tendency of this B point to move towards the right side, okay. That's why the VB shown here. So VB component will come here. So VB component with us here, VA component with us here. Draw one line perpendicular to this VA component, extend this line at the back side, and extend the line from this B point towards the back side. So intersection of this line and this line occurs at this spot. So this is nothing but the instantaneous center I. Now what's about the angle? Why we need the angle here? Because my target is to get the value for this one, length IA and IB, okay. So here in this case, if you just see here, this angle is given 40 degree. If I drop one line perpendicular from this A point, okay, to the bottom line, okay, then what's about this angle with us 50 degree. So same angle we can get here 50 degree, because the same line with us, this angle and this one is the same one, same angle, okay. So here we can get the 50 degree, here we can get the 50 degree. So this angle with us 40, 50, automatically we can get this angle as 90 degree. So from this geometry, my first aim is to get this one, this length, okay. So I can get this length. For that, this angle with us 40 degree, this one with us 50 degree, okay. From geometry you can get the easily value for the same by using the trigonometric function. So here the sine of 40, if I use the sine of 40 equals to, so what's about this length, assume this one is nothing but the h divided by, what's about this one 300 with us. Now by doing the calculation we can get the value for this h equals to 192.84, we can get from this one. So once we get the this one, my next target is to get the value for this one 5. So here this actually length with us h equals to 192.84, this length with us, okay. Now easily you can get the value for this one theta or 5, okay. So this one sine of theta equals to h front side divided by this one 800. So you can get theta equals to 13.95. now using the sine rule, okay, if you once we get the value for this one phi as 13.95, okay, let us consider this one as theta, okay, because here theta notation used by us, okay. So here theta is nothing but the 13.95. I use the sine rule. If this one is 13.95, so what's about this one, this must be 90 minus this one theta, so we can get 76.05. so this angle already with us 50 degree, this one with us 76.05. so what's about this one, this angle must be 180 minus addition of both the angles, so this angle we can get 53.95. so in this way you can get all the angles. So once we get all the angles, now use the sine rule. So what's about the sine rule, so to apply the sine rule, whatever this length with us, you just see here, name given for this one as AB. AB divided by exact angle, okay, this one sine of 50 with us. So in front of this length, this is the angle with us, so AB divided by sine of 50. Okay, now what's about the next one? IA divided by, so what's about this angle? 76.05. so IA divided by sine of 76.05 equals to IB divided by sine of 53.95. so in this way, just write the sine rule. So once we write here, we know the length AB 800 mm with us. Just substitute here 800 divided by sine of 50. Equate this term with this one and equate this term with this one. So by equating this term with this one, what we get here? Automatically this one sine of 76.05, this term will goes here. Similar case with this one IB. For that, this term will as it is keep as it is, and this one goes towards the left side or comes in numerator. Okay, so after doing calculation, we can get the IA equals to 1.04 meter and IB equals to 0.844 meter. So once we get the IA and IB, now rod AB, now just focus on this rod OB. Just here, the tendency of this rod to move about this point O in a rotational way only, means this one OB possesses only rotational motion. And what's about this one AB? The tendency of this, if you just see, if you focus on the B point, the tendency of this one to slide over the surface, and the tendency of this A point to slide as well as rotate. This possesses the general plane motion. Okay, now you just see rod OA. With respect to this rod OA, write the formula. Rod OA is here. So what's about the formula in this case? OA multiplied by angular velocity of the same link. OA multiplied by omega OA. Okay, so omega OA already with us 2 pi, and the OA with us 0.3. OA with us 0.3. So substitute here. OA equals to 0.3 multiplied by 2 pi, we can get the 1.89 meter per second. What's about the rod AB? Rod AB performs the general plane motion. Okay, now just focus on the A end of that rod AB and B end of the rod AB. Okay, now with respect to A end, write the formula. VA equals to IA multiplied by omega AB. Now don't confuse in the formula written for the previous case and in the next case. Whenever any rod possesses the general plane motion, okay, you need to consider the distance away from that particular link or outside of that particular mechanism. Okay, so here we are considered the IA distance. In the previous case, the rotational motion is possessed by this link. Okay, so that's why we have considered the distance that particular link. Okay, and if you just see here, A point is common between the AB link and OA link. Okay, now the formula written in case of that VA equals to OA multiplied by omega OA, and here VA equals to IA multiplied by omega AB is written. Okay, so how that formula is written differently? Because if any rod possesses the general plane motion, then you need to consider the distance outside of that mechanism. Okay, so here IA multiplied by omega AB is written. So what's about the omega AB? For that we know this one VA equals to 1.89. What's about this one? What's about this IA with us 1.04. To the calculation, we can get the omega AB equals to 1.817 radian per second. So what's about the VB? For that also write the formula. Now consider the B end of this one. Initially we have considered the A end of the same rod. Now consider the B end of that rod. Okay, and just develop the formula. So in this way we can get the formula in case of the VB equals to IB multiplied by omega AB. So what's about this IB? My task is to get the VB. For that, IB already with us. IB is here 0.844 meter. Just substitute the value for this IB here. Omega AB with us 1.817 radian per second. Substitute here, do the calculation, we can get the VB equals to 1.53 meter per second. Hope that the problems on this kinematics of a rigid body by using the instantaneous center rotation method clear to you. Thank you.